Hello, everyone, and thank you for joining Families Building Back Better after the Marshall Fire at the 2023 Passive House Network Conference. My name is Jessica Hunter. I'm an architect at Boss Architecture in Denver. I will be joining the presenters today as your moderator. At the end of 2021, in less than 24 hours, the Marshall Fire destroyed over 1,000 homes across Superior, Louisville, and unincorporated Boulder County here in Colorado. Today, families are building back. We will be hearing from 3 distinct project teams that are building back to Passive House standards to hear about their approach, how they are providing affordable, resilient, high-performance homes. During the presentations, please ask your questions in the chat. At the end of the session, we'll have a panel discussion to circle back to some of the questions you have asked. Before I introduce our first presenters, I want to provide some context that is important to understanding the challenges faced after the Marshall Fire. The circumstances of rebuilding after natural disaster, wildfire, or otherwise, heightens the challenges of time and budget, often at the expense of performance. Marshall Fire was no different. First and foremost, none of these homeowners planned to build a house and had no idea how to navigate the construction process. This is exacerbated by the fact that most insurance policies in Colorado and generically across the United States only provide 24 months of rental housing. That leaves 2 years for homeowners to find temporary housing, navigate insurance, hire a team, work through the design process, get permits, and complete construction. Come January 2024, most homeowners will have used their rental coverage. In the case of Marshall Fire, 92% of homeowners were underinsured by at least $100,000, and many by amounts of $250,000 or more. And that is just to replace the home they lost while meeting the required building codes. Homeowners must independently finance any amount they cannot negotiate through their insurance companies for replacement, along with any performance upgrades they want to invest in. For many, even rebuilding a much smaller code-built home exceeded the insurance coverage they had. Because of this, there were a number of local efforts to assist Marshall Fire homeowners. Less than 2 months after the fire, Xcel announced a rebate program to incentivize homeowners to build better than their local energy code required. The program has a tiered set of rebates ranging from 2021 IECC to Passive House. Homes achieving Passive House, which include PHI Low Energy, PHI Classic, and FIAS, receive a rebate of $37,500. Later in the year, the Colorado Energy Office announced an additional $10,000 rebate for homes designed to be all-electric ready. That provided a total of $47,500 to all electric Passive House projects. These programs helped homeowners rebuild more sustainable and more resilient homes without the full burden of the additional costs. In the Marshall Fire, 1,084 homes were destroyed. More were damaged, which totals to more than $510 billion of damages. This only accounts for 1% of all the structures lost to wildfires since 2005. 1%. From 2005 to 2022, nearly 100,000 structures were destroyed by wildfires alone. Marshall is not the first of its kind, and it's not the last. The projects being presented today represent a path forward for resilient, healthy, passive houses and set an example for what is possible following a natural disaster. Presenting, we have Maggie Wholtjen from Shape Architecture and Frank Wetenkamp from Wetenkamp. Please see your program for full bios of all of our presenters today. Maggie, Frank, thank you so much for joining us today.
Thank you, Jessica, for that wonderful intro. And thanks to the Passive House Network for hosting this and giving us a chance to return to some of the design considerations and details while we're in the middle of construction for most of these homes. I'm Maggie with Shape Architecture. I'm working with Frank from Wetenkamp Design Build, and we'll be talking about the Sunflower Sanctuary named by its owners, Kevin and Casey Lombardo. And quick shout out to them. They have been absolutely amazing and instrumental to the success of this project. Super open-minded, they push us on performance, and just a delight to work with. So why Passive House? We get asked this question a lot, and aside from the obvious Xcel incentives that were offered and that opened the doors to a lot of people who wouldn't be looking at Passive House otherwise, the Lombardos were motivated by their children and their respective futures, and just the growing need to build resilient homes. in an era where, as Jessica said, wildfires are becoming the norm. There's 100 reasons to build passive, but these days I think it really all boils down to resiliency. So with this in mind, and probably actually one of the most unique aspects of our process is how integrated and highly collaborative the design team has been between Shape, the Lombardos, Livingcraft, our structural engineers, even our landscape designer, and Ed May with building type, which we'll discuss a bit further on. So getting into the design a little bit, to respond to the owner's desire to have basically the same size house as they had before, but make it a passive house, we started out with the most simple geometry that we could come up with to optimize the surface area to volume ratio. So as you can see in this diagram, it's really a cube, and we removed the garage from the thermal envelope and just had this cubed thermal living spaces. And we actually got the surface area to volume ratio down to about, I think, like 0.25, even though most homes range between 0.7 and 1. And then after doing that, we were able to make adjustments, just small adjustments to optimize passive and active solar. So for instance, rotating this roof to be south facing to put solar panels up there, and having these south facing glazing and west facing glazing to allow light and heat into the home in areas where it could be distributed in the wintertime. Shaded entries both on the lower level and at the roof deck, and prioritization of indoor to outdoor connections. So this is our lower level or entry level plan. The entrance to the house is here, takes you along a corridor that leads all the way to the backyard, where we have offices and bedrooms. As you can see, this red line denotes the thermal envelope, the garage being outside of it. This is the main level plan. This is the plan where that south and west facing glazing really comes into play. It allows heat to come into the main central area of the house in this open living, dining, kitchen space, and also provides access to the exterior here. This is our upper level plan, and what's important to note here is that we have western facing glazing to allow heat into the space, into sort of an artery of the upper level to allow heat to distribute that way. So this graphic from building type just kind of further drives home that point a bit, that most energy demand in passive houses comes from the heating, hot water, electrical equipment. So we were really cognizant in the design process of things like stacking plumbing and placing the windows, like we were just talking about, strategically to allow heat in the winter months, but also wanting to conveniently frame the windows to look at the mountains. Okay, so one example of a collaboration that we had with building type when we were designing the windows, we discussed the layout with them, and they suggested that we make two changes to our design. One, they wanted us to reduce the north-facing windows by a tiny bit, just to reduce the energy loss through the north. And two, they needed us, they made it a point that we needed to keep the west-facing trellis shade structure to reduce the amount of heat, unwanted heat, coming in through the west side. And normally there's this push and pull between, wanting to frame mountain views in these mountain towns, and then also placing windows strategically to optimize passive solar. But this project, I feel, is really unique in that its site was perfectly arranged to have both. And so assemblies are another really great example of our team's collaboration. Very early on, we discussed using the double stud wall assembly. Frank actually came up with the idea after seeing sort of our relatively simple geometry and sort of determined it would work. Then building type verified that we could get R43.3, and then we integrated it into the structural design. And because we knew we'd have this interior service cavity here, we didn't have to avoid putting plumbing fixtures on the exterior walls, which allowed more flexibility in designing the floor plans. The roof assembly here came from the structural engineer, and then Frank also suggested we have a service cavity there for electrical fixtures. And then for the ground floor, for the lower level slab on grade, we actually have 10 inches of EPS foam below 2 layers of 3/4 inch plywood and engineered flooring above. And because the Louisville Building Department had never seen this before, they actually flagged it in our permit review, at which point our structural engineer, who is also well versed in passive house design, stepped in and advocated for it to get it approved, and it worked. We call it a slabless slab, and in addition to reducing material embodied carbon, it also has a higher R value than a concrete slab, coming in at R43.7, but with a strength of 25 psi, it's plenty for supporting residential functions. And R values actually had a big impact on our decision to go PHI low energy as well. You'll notice that there's not really a massive jump between the code minimum R values here and these PHI low energy building values that were recommended to us. But there is a fairly substantial jump between PHI low energy and PHI classic. Low E classifies or qualifies for the rebate. So since this lot was constrained in size and the budget was tight, we opted to not pursue PHI Classic after we determined that it would add enough cost to sort of negate any increase in performance. And then very quickly, before I hand it off to Frank, we had the challenge of detailing windows set in concrete, but in a way that would prevent thermal bridging. We originally had the window jamb set sort of horizontally in line with this concrete stem wall here. So the owners would actually have like sort of a shelf on the interior. But when we shared that detail with building type and they did an isotherm analysis, we learned it would be at risk for condensation. So after several discussions with both building type and Living Craft, talking about our options through the lens of like what's actually buildable, we figured out that we could solve this issue fairly simply by just moving the window further in towards the insulation. And that's graphically represented by this isotherm. And with that, I will go ahead and hand it over to Frank to present some of the lessons learned during construction.
Thanks, Maggie. Yeah, it's been a really great collaborative experience, and first lessons learned are most of the lessons we're learning are similar to standard construction. It's just the details are so much more important, and first and foremost, it's like having those meetings ahead of time. In particular, something that I wish I had done a little bit earlier was getting the architect, engineer, passive house consultant, and builder all in the same room to run through the plans for like an extended period of time, just because, someone draws a detail slightly different than someone else, and then in the field, we have to kind of figure out what's buildable. So spending a little more time on that, I wish I'd probably done that. But so far, things have gone well, and, when we do run into questions, those RFIs turn around pretty quick, and so far the project has gone really well. One thing that we did as builders was we kind of just started marking up the drawings just to wrap our minds around it, and also so that we can kind of relay some of this information back to the designers and the passive house consultant, and also just to kind of share that information with a lot of our subs. And that's another thing that was even more important on these types of projects versus other ones, which is getting your trade partners through early and figuring out where are we going to put that radon stack? Where are we going to put the vent through the roof? How are we going to run our line set? How are we going to air seal all these penetrations for the ERV or, hose bibs or whatever they may be? Kind of figuring out all those things early and getting them on board for this whole really tight envelope idea was really critical, and finding people who are open-minded to that was also really critical. You don't really want to work with a grumpy person, because then if they're not bought in, then who knows what's going to happen when you leave site. So that was really important, and we found really good team members for that. So yeah, this slide is just kind of I went through, marked up all the details, all the different products I was using. I also met with the supplier. They're kind of like an air sealing consultant as well. I used 475 Building Supply for that. So they kind of helped me develop this. I met with the framer. We revised it even further. And then, when you get into the field, a few of these details change as well. And if you go to the next slide, it's basically the same thing, just looking at window and door details, just kind of marking those up. what products are we using, how are they connecting, how does that red line around the building all connect, because every little detail matters. And trying to wrap your head around it ahead of time definitely made things go smoother, so you had a reference. But even so, again, it's like then you get in the field and you're like, oh, how would I actually like fold this thing to connect this other thing? And so it's always a little tricky, but so far we've done well with it. For a lot of our goal with this was kind of trying to do more of a low carbon build. And so anytime we can avoid some of the higher embodied energy materials like spray foam, we did. So most of this is above grade is dense packed cellulose. So for that, we did a double stud wall with surface cavity, as Maggie mentioned. And so we're using a lot of membranes, a lot of tapes. And so the details are a little tricky sometimes and take a little time. And so, something else I would definitely recommend if someone is new to this is whatever you think your air sealing numbers are going to be, increase them. And then whatever your material takeoffs you think you're going to do, like order more tape. Because there's always things that you're like, oh, I should tape that too. And another thing is we just kind of have someone on site basically all the time, which a lot of times is just the site supervisor, which is just kind of our air sealing guru who's just staying ahead of the framers, phasing out all those little details, which we can run through now. So if you go to the next slide, this just kind of shows the slabless slab. So we did our vapor barrier underneath foam. We had to get that grade super flat and level and kind of perfect, because any little imperfections can definitely move the foam around, and then you don't have the self-leveling advantage of concrete. So it is a little tricky, but we had good trade partners for that. Sealing all those penetrations down below, having the vapor barrier outside of our insulation, I think helps the insulation perform better, but also just protects our air barrier, which is nice. And so, that first top left is the vapor barrier as we're installing the foam. Then you can see the foam installed in the bottom left. And then on the right side, that's that same level with the 2 layers of lapped T&G subfloor on top. And now it feels really solid, pretty level. And so it should work out well. It's new for us, but I've always wanted to do it. So that vapor barrier wraps up and connects to the inside of that foil-faced foam. And that foil-faced foam is now our air barrier to the interior. That's 4 inches of foam directly on the concrete. We insulated to the interior of the concrete for various reasons that I won't get into, but you can kind of see that with the window bucks. And then on the right side, in that top left photo on the right side, it's that same wall on the bottom, which is a double stud wall that is on the same wall as the garage. So we kind of have a little bit of a transition there. You can see the double stud wall on the right side, that's 12 inches. You can see that blue tape is kind of wrapped underneath the 2x6 wall, which is our structural wall. That's all just kind of connecting the air barrier at every lap. So we had a lot of the details on this project are a little funky because we're trying to do it foam free. And so when you have a cathedral ceiling, but you want to do dense packed cellulose and you are worried about condensation, you kind of go about it 2 ways. And we did basically both of those ways, which is you have a really robust interior air barrier so that in theory, you don't ever have warm, humid air getting to your exterior sheathing and condensing there. Or you can vent to the exterior. And that's basically what we did. So we have an air barrier to the underside of the TGIs, which you'll see in the next photo. But essentially, just imagine you have your cathedral ceiling, air barrier underneath them, and then on top of that, we have this Mento, which is doubling as the netting for the insulation, but also kind of like a WRB. And then there's an 1.5 inch vent above that, kind of like a rain screen that you would do on the exterior of your walls. And then your sheathing sits on top of that. You'll also notice that we have kind of intermediary purlins between our 2x4 studs, and that's basically just to prevent the insulation, once it gets dense packed, from kind of filling that void too much. They're just kind of spacers just to hold that back. And then we're doing a ridge vent, and we used well, we use Vulcan vents, which is basically a fire rated intumescent vent that will close up in the case of high heat. So there is some fire durability built into this design as well. But there's a lot of layers there. It's not the most straightforward solution. Granted, we're still doing this pretty cost competitively, so things were learned. It's still simple in terms of construction. It's just a lot of layers. And so you can kind of see this is that third floor. That's the intel on the bottom side of those TGI roof rafters. We do a service cavity basically everywhere just to fish wires and have slim can lighting and switches, outlets, all that kind of stuff. Just to keep all those things to the inside of our air barrier. That way, the fewer times we have to poke through that, the better. The less taping we have to do, the less chance for failure. And the nice thing about passive house low energy is we only have to get below 1. I'm hoping we get way below that, but I guess we'll see where it turns out. We have windows coming in next week, and then we'll do a little preliminary blower door to kind of see where we're at. And then the exterior is basically just wrapped with a WRB. It's a vapor variable WRB. It's Mento from 475. And then we're doing a vertical rain screen and metal siding. Again, the metal siding was another choice for a little bit of a fire durability choice. The one thing we learned on the vertical strapping that I had done diagonal strapping before, but for vertical, in order to land on your studs, you really need to stack your studs from floor to floor, which we did not do. So we ended up just going back to the engineer and being like, what screw do I need to use and what spacing do I need to use if I'm not going to a stud? So things like that you learn along the way. You'll notice that the vertical battens, as they come up to the windows, are held off. That's just to allow air to kind of move around as it goes up that kind of stack effect. And then we also have Vulcan vents at the bottom that kind of act as the bug screen and fire screen, just to prevent any embers from kind of going up through that vent. And causing that chimney effect and bringing fire through. And that's kind of it. I think from our point of view as a builder, our values really line up with the designers at Shape, Maggie, and then the clients as well. And the high performance, the low carbon, the healthy materials, that's kind of our jam. And so this is a really great project for us. We're really excited about it. Ultimately, as on any project, we're worried about budget and performance and comfort, resilience, health, durability, all those things. And so I think that Passive House lends itself well to all those things. But having a good team, coming up with a good system is super important. So anyways, that's all I got. I appreciate it.
Thank you so much, Maggie and Frank. It was great to hear about Sunflower Sanctuary, and I'm sure there'll be a lot of questions for you in the chat and that we can come back to during the panel discussion. Next, we are going to hear about the Restore Project. Presenting, we have Rob Harrison of Harrison Architects and Chuck Bauer with Joubert Homes. Rob, Chuck, I am going to hand it off to you.
Okay, great. I want to thank everybody for this opportunity to speak with you all today. And I'm going to be joined by the builder, Chuck Bauer, who's going to talk more about the what's happened since the permit was submitted. And I also wanted to acknowledge our collaborators. Andrew Mischler was instrumental in doing the Passive House modeling, and then Vlad Pesol also did some therm analysis. As Bronwyn Berry famously said, Passive House is a team sport, and this, like Sunflower, I think has been was a very collaborative effort along the way to get this in for permit. This project is in the Sagamore development in Superior, which had some, it's a planned unit development, so had fairly small, narrow lots, which really drove our design. Um, and our response was basically to um, not build over the entire garage in this project, but to sort of wrap the house around the garage, which gives us a little more room for a setback between the buildings. Um, the general idea with this project was to develop a stock passive house that could be rotated and flipped and mirrored on different lots in Sagamore, and then that we would gain some economy by repeating the design, and that I believe is happening. Um, the So this is a rendering in twin motion from very quick um, of the initial idea, um, and then this is a picture of the actual house. This is actually a picture that the clients Peter and Michelle Ruprecht took a couple of months ago. So I'm hoping Chuck will have some great shots of what's happening now. I know the windows were about to go in a couple weeks ago, so that's exciting. We are at permit submission anyway. We were targeting PHI Classic. Um, we'll see how that works out. I'm going to show a little of this is the ArchiCAD model. So we're basically looking at it with the siding and that Peter and Michelle chose. So basically you can go to the plan. In this case, the north is up. This is east over here. There's another house on the north, another house on the south. So on the ground floor, it was a wedge-shaped lot, so we could expand the size of the garage a little bit. And this is unusual in that it has a basement as well, and then second floor. So we Andrew and I worked really closely with Chuck through the design process to come up with systems that would be both economical and meet passive house. Like Sunflower, we're doing wood stud walls, except that we're doing 2x8s with 2 inches of mineral wool on the outside. The mineral was chosen because of its fire resistive properties, and then rain screen, and then fiber cement on the top of that. And then a metal roof, which Chuck will speak to later. We have parallel cord trusses as the roof, with blown-in cellulose, and then actually these are 2x on the flat as a insulation space, and then the basement is a regular slab with EPS underneath. We looked at doing a slab-free construction, which I think is a great thing that they're doing on Sunflower, and but we couldn't do it with the basement. At least weren't able to figure that out. The other so basically we've got blown-in cellulose in the walls here, and another thing that I looked really carefully at, might say obsessively, is is the spacing of the studs to have, this is the advanced framing grid here, the stack framing, to make sure that they lined up floor to, or basically from the foundation to the roof, and then the studs lining up with that too. Chuck suggested that we use deep floor joists, open web, to give us room to run the utilities and so on in the floor space of both the first and second floor. Let's see what else. Like, go back to the 3D here. Like Sunflower, we had, like most mini houses in the area, the view is to the west. So we partly mitigated the heat gain with a continuous deck off the west side of the structure. And we were lucky in this case that because of the pie-shaped plot, we had a little bit more space in between the two houses, so we could get some more glazing in on the south side. The north remains fairly low on windows, which is something that's different from what we need in Seattle. I think I will turn it over to Chuck, and I can jump in if there are any other questions at the end. Thanks.
Thanks, Rob. I think that's a pretty good high-level view of what we're trying to achieve. The biggest challenge that we had going into this is that we wanted to check all the boxes, not only be passive house, but WUI compliant. So that drove a lot of our exterior materials. The decision was to try to have everything non-combustible outside of the air barrier, or the WRB, excuse me. And so all the decks are steel with aluminum deck boards, steel railings, cement siding, and standing seam metal roof on this. So that was the challenge. We also wanted, like Rob said, is to introduce advanced framing to this, and at the same time, try to get it affordable or more affordable for clients that were coming up short on their insurance claim. And so that was kind of a tall order. It took us months and months to finalize the plans. We're still value engineering out in the field and coming up with the best ways to do this. I did want to highlight that with the metal roof, and it's funny that Frank and Maggie went into this on their project. We've started out with a non-vented metal roof, and during the process, realized that a non-vented metal roof and passive house and was a little bit difficult, and so we actually switched to a vented roof that looks very much like what Frank was describing. So, and we're going to implement that same roof assembly on house number 2 and 3 in the subdivision as well. So that's kind of a something that I wanted to bring up that I found interesting. This is our first passive house build as a contractor, and the learning curve has been a little bit steep on it. I won't deny that. I think every day our trades learn. I learn on how to be better. It comes down to basically sequencing in the details is what I've determined. If you don't have the sequencing in the details down correctly, then you're going to be spending a lot of time and money correcting those things that should have been done, a week before the, some framing components went in. So that's probably the biggest takeaway from our project to date is that just getting all of our trade partners up to speed on what the best way to put this together, and then hold them accountable and look forward to the next project for things going a little bit smoother.
Last but not least is the Enclave House. Presenting today is Kim Cinco of Baseline Design, along with Mark Attard from Hammerwell. So I'll hand that over to you whenever you're ready.
I'm Kim Cinco from Baseline Design, and we're going to talk a little bit about our Enclave residence fire rebuild in Louisville. Mark Attard is here from Hammerwell, who is building it. And on the Passive House side, we also had Steve Mann as our Passive House consultant and Tad Everhart as the certifier. So we're in construction, slated to move in around the end of the year. So we want to talk most about where we're at in construction and kind of some specific design and construction considerations to do a passive house and what we ended up doing and maybe what we've learned and some takeaways. But I'll give a quick overview because I know not everyone will have seen the project. So this is it from the street. It's a ranch style home, about 2,700 square feet over a partial basement. And this is it from the rear yard. So behind us is Davidson Mesa, for anyone who's local and knows. And behind that, just unobstructed mountain views. So obviously driving goal is to get big, huge, awesome views out the back. And then a few views inside, renders currently, but we're looking forward to once these will become photographs. So on the right-hand side, that's the view out to the west with the mountains. And then we also have this idea of these tiered southern clerestories to take advantage of southern light and just flood the house with really lots of natural light. Just click through a few more views. This is the main entry. So coming into the house and looking directly out the west. Coming in a mudroom door from the garage, but through the house you get, again, an immediate western view. And then here the main open living space just from the other side. So living room, kitchen, dining. So we thought we would pick a few specific design considerations. What do we have to do differently to design this house because it's passive? And then more specifically to kind of talk about using a prefabricated system like Be Public, which is what we used. So the large 14-inch thick Lego blocks that come on site and go up really quick. We can kind of tell you what we've learned and takeaways from that. So I'll talk about them a little more from the design side, what we found we had to specifically do, and then Mark at the end will talk about it from the construction side. This is the state of the house at the moment. And I would say the first thing design-wise, like most high-level process that you've got to do differently for a passive house, for us would Be Public, but really for any passive house, is what everyone here is saying. It's the team and it's the coordination and it's how upfront the coordination is. So I've had a lot of people ask, is there a lot more planning, more detailing, more coordination for a passive house? And I have not found that to be the case more than any other custom home, but I have found it to be much more front end loaded. So by the time this was going in for permit, it's really dialed in with all the players, from the details to the systems to everything. And then the process of construction is much more execution of those than as much figuring out as I'm used to. So it's good. It's a good microcosm or good practice for any project. But I would say that for sure is one thing we've learned, just how crucial that front end coordination is. From getting a great team with lots of expertise and just caring about it and lots of passion, and then just getting that much farther along before you're starting construction. And just generally, this is a diagram we did really early on showing the layers from the plan to the panel components in the middle and then the cladding on top. And I think what I'd say as a takeaway is we didn't feel limited by it. Going into it, I thought that we would. We thought there would be a fair amount of design concession for performance. And we really haven't found that to be the case. It's a parameter for sure, but I would say the plan, which initially came right from the owners, is really close to what they wanted. All the light, all the windows, really close to what we would want to do anyway. So we feel super encouraged by that. And I think that's like a nice nugget to be able to pass along to people thinking of doing it. This doesn't box you in or limit you, just changes a little bit how you think about it. Ground level plan here. And again, this was where it was when it went in for permit, and it has really not changed. And some sections here. So then I was trying to think about a couple specific examples of detailing, because we could take anything. We could take sort of how the prefab components meet the site-built parts. We have a standard poured foundation, so that has some interesting thought in detailing. Our garage is also outside the thermal envelope, so that is a site-built component. You could take any number of other, considerations and sort of do a presentation about it, but I thought I would just show this example, which is planning for windows. So specifically with the Be Public system, there's several ways to do it. When we started, we thought, okay, they have a standard set of panels with standard sizes, and you pick from that, so that might potentially be limiting, and we really didn't find that to be the case. But this example on the left, that is a panel with a pre-cut opening. So these drawings are from Be Public, the company where we got the prefab wall components. And they have certain sizes, and you can pick and use their standard panels. You can also make custom size openings too, and we did that in some instances. But so that's one option. The middle one has even a little bit more flexibility, which is basically making a built-up opening. So using separate wall panels, and then this is a sill panel and a header. And then again, because those come in all different sizes, you have even more options for how to size that opening. And then the last one here is really just residual space. So we have roof panels stacking, and the space between is where we put clerestory windows. With all these, then there's a whole slew of other window detailing considerations like Maggie was getting into. So where within this thick 14-inch wall do we put the window? How much do we over insulate on the inside? So working closely with our passive house consultant on energy modeling of that was crucial. So this kind of had early coordination components of how to put the panels together in different configurations, and then within those openings, how to detail around them. One other window condition. This is our largest window out to the west. It's 20 feet wide, 9+ feet tall, lift and slide. So this is yet one other way to kind of work within the panel system. The Be Public panels themselves, the opening is oversized. So it's the line here at the very top of this header, and then several extra inches on either side as well. That was for a few reasons. One, we were still cycling through window systems and pricing them out, and different manufacturers have different maximum heights, so we didn't know exactly what we'd be using yet. So that's just a nice example of, as much as you need to get everything set early on, if you have a certain variable isn't determined yet, you can find ways to work around it. And second, it helped us with some detailing. So at the top, we're going to want to have a concealed shade pocket there, and just sort of let us get some alignments and some finished detailing that we wanted to do. So it's one cool thing about this system is it's the whole envelope, but you can build in flexibility where you want it. So I thought the the window design on this project is just kind of a good example in general of how I feel about this process, which is something that might feel really limiting and come with certain parameters at the start. Actually, if you're creative with it and use it in different ways, you can really kind of design around and work to your advantage. And we didn't feel like we didn't get to do what we wanted to do. Then I'll share one more example of kind of design considerations specific to Passive House and specific to Be Public. And this one is in the same vein of working with everyone early. Working with the jurisdiction early was super important. So we found Louisville to be wonderful. They were really open to Passive House and to kind of changing the way they're used to reviewing. But I'm sure that some jurisdictions would have a harder time with it because it is really different than things they're used to seeing. The standard manuals, JDS, really don't apply, lots of things. So getting in front of them early and often for kind of pre-submittal reviews, if that's possible, is something that we found to be really helpful, and I would definitely encourage anyone doing a Passive House to do. This specific example is just showing that, of course, with really thick 14-inch walls, you have a larger footprint. So this is our site plan, and this is a diagram showing that we really built out to the full extent of our setbacks. And that was even with Louisville providing a Marshall Fire rebuild setback variance where they let you bump out 10%. So my kind of takeaway or look ahead from that would be, to any extent that we all have opportunity to talk to jurisdictions, I could see a version of like Passive House setback variance, that if you're going over a certain thickness of wall, you should be allowed to kind of bump into those a little bit. This is a pretty big lot and we were able to fit, but there's a lot of scenarios where you're really tied up against those constraints. And I could see that being something that tipped the threshold that someone wouldn't want to necessarily do this. So worked out, but again, just working with the jurisdiction super early, working with all consultants really early was something that we found to be really helpful. So then we can show a little bit about some of the construction. And Mark, I can flip through these and let you speak to construction considerations and things we did and things we've learned and whatever else you want to share.
Sure. Thanks, Kim. And thanks, Passive House Network and everybody on this panel. I think all these projects are really excellent, and it's cool to see the progress that's been happening over the last few months. So, when Hammerwell started to get inquiries into our services for building back some of these projects, and specifically the projects that people were interested in Passive House, we had been talking about ways in which we could implement Passive House into the way in which we like to build, and do it in a way that would be less taxing. We're not as smart as Frank's crew, so we felt like we needed to go to a kind of a simpler approach, and the panelization we felt like was a really excellent way to address a lot of the details that go into Passive House, specifically around air sealing. So the one thing that we really liked about panelization was that each unit is self-contained. We know it has the proper insulation values. We know it's already an airtight unit in and of itself. And then when those panels come together, which Kim, I believe we have on our next slide, we can see some of those. When those panels come together, you can. There's actual obvious places where you need to air seal. So it makes it simpler for our crews who maybe aren't used to the air sealing process. Um, we just have to point out the fact there's a seam, some tape needs to go there. One of the things that we did need to figure out is exactly how we were going to transition from our foundation to the panels, and particularly in an air sealing, from an air sealing point of view. So that is one of the things that we worked on with Kim and with Steve Mann specifically. And really, what it became was a very simple process of draping over some air sealing material. In this case, we used Intello. It's kind of hard to see on this slide, but we draped it over the top of our plates, and then that allowed us to tie that into the foundation walls, and then we could flip it up and then tape it to the outside of the panel and give us a really nice air sealed joint. Right now, the material is there. We haven't finalized our taping along that particular seam, but we have all of the outside of the building taped, and we have begun to tape all the inside of the building, with the goal of doing our preliminary blower door test next Friday. As you saw in previous pictures, we already have windows and installed. And so one of the things that we did as a team, as a crew, is we decided to give different air sealing responsibilities to different crews, because and we felt comfortable doing that because we do have this panelized system. So our framing contractor who set the panels, they're responsible for doing the taping on all of those seams, and primarily because the way those panels come together, they have to have these Simpson clips that are put strategically at various engineer directed locations, and we need taping on those seams before we can put those clips on. And because the framer was responsible for those clips, we made him responsible for the tape. For the window install, we used a different subcontractor than we use for installing windows than we use for framers. Sometimes they do both, but in this case, we separated those out. And our window installer was responsible for all the taping around the windows, both inside and out. So it was a little bit of a different process there as it related to not having one particular crew responsible for all air sealing. But ultimately, as the general contractor, we feel that as long as those details are provided, which Kim did provide, and we manage those two crews appropriately, we should be able to achieve the projected air sealing expectations of this project. And one thing that I did fail to mention is at the beginning, this is a PHI Classic home, so we are shooting for a 0.6 ACH. Right now, I mean, of course, it's modeled. It's just modeling at this point, but we are expecting to be able to hit an ACH of below 3 with using these panels. And if we do that, we are expecting our total KBTUs per square foot to hit below 3 as well, to be about 2.75 KBTUs per square foot. So this is going to be this house using this system, we feel is going to be even beyond what Passive House requires. And I'm really excited for next Friday for our initial blower door to see where we end up at. But I'm feeling pretty confident at this point, just given the execution of the details. Oh, and Kim is giving me another one to talk about.
You don't have to. This is just some construction photos.
So you'll notice here, you'll see those clips that are long. So everywhere where you see those clips, there's a seam.
And at that front there, you can see that there's actually 4 pieces that make up that wall around the windows. Actually, more than that, because we're stacked on top of that. So we have a sill piece, 2 jamb pieces, and a header piece, and then our stack up beyond that. And each one of those clips is required per the engineer. And this photo was taken. I don't know, when was this photo taken, Kim?
This is probably a week at least ago.
Okay, so we should be pretty close to having all. I mean, it's all taped. We should be pretty close to having all those clips in within the next couple of weeks, and ready to move on for a framing inspection soon after. And with that, I think we're done. I think the last thing that I would say is is that concurring with everybody else here on the panel, having the team together and collaborating up front and working through all those details, I think it really helps your construction team to really understand how things are supposed to come together, and it just makes them more hyper aware of the project. And so even though it might cost a little bit of money up front to do to involve that collaboration, and also, as Kim mentioned, that front loaded design time, I think in the end it makes the construction side of things go a lot smoother.
Thank you so much, Mark and Kim. It's really great to see this project come together. Those presentations were amazing. I know I've been tracking these projects since early design, so it's been really incredible to see them evolve. One of the topics that we talk about a lot relative to Marshall Fire is affordability. And how do we make Passive House affordable? Affordability comes in use of time on site. It comes in, thoughtful use of materials. So I kind of want to just start there on each of these projects and talk about the strategies you're using specifically because of the financial challenges that all of the Marshall Fire homeowners are facing. Rob, I want to start with you. I know that your concept from start to finish was really creating this ready-made product that homeowners could opt into, that had just really fantastic performance. You're also going for WUI, which is incredible. Obviously, that's, so important, especially for Sagamore, who's out on kind of the leading edge of the boundary and has probably the most challenging sites across the board in the Marshall District. Can you just talk about some of the primary design strategies you talked about early on and how that solved for affordability?
I think one of the, like everyone else here, I think we were really trying to minimize the surface to floor area ratio. But also the garage was a real challenge. That was part of the zoning of the development. So a front-facing garage with 2 spaces, and then 2 spaces in front of the house for off-street parking. So that really drove the shape of the design. I think that working with Chuck all through the process was instrumental, really, in keeping the cost down. I think both Maggie and Mark and everybody actually has been talking about the collaborative aspects of the work, and that was a huge part of it. It was a little complicated for us in our partie by wanting to make the house something that could be rotated and flipped and mirrored on different lots. So we had a gable roof that basically had a roof plane facing in every direction, so that if homeowners wanted to add solar panels in the future, that they could do that. So that pretty much drove our the massing of the house. Otherwise, I think it was really the getting continual feedback from Chuck on what things were going to cost. We started off with the intention of doing panelized construction, but then Chuck really looked carefully at what that cost was going to be, and we found that the assembly that we ended up with, which was basically 2x8 studs with mineral wool on the outside of the sheathing, was going to be both the least expensive and the most economical in terms of the width of the assembly on this small lot.
Yeah, I do think you have I was kind of like tallying the inches per wall for each of these assemblies. You probably have the thinnest assembly, and you certainly have the most constrained site. So I think that that makes sense. It's funny because in my experience, a 2x8 wall with mineral wool is not an inexpensive wall though either. It has a ton of benefits, both in terms of vapor drive and fire resistance and carbon footprint. And so that's really incredible. I know Chuck is trying to join us back. So if he does, I'd love to talk to him. You did end up using, as I understand it, like a ready frame system though, something
Yes.
that kind of streamlined fabrication on the framing side, which isn't necessarily tied to your passive house strategy, but did accelerate construction. How do you know anything about how that experience was, positive, or the prep involved in that?
Hopefully Chuck will be able to chime in when he joins. But the Ready Frame, for those who don't know, is basically a prepackaged, pre-cut system of framing where every stick is labeled with where it's going to go, and so it's not a system that I've worked with before. So Chuck would really be able to address that. The other thing I wanted to mention just is in the feedback loop that we had, that Andrew was really looking at the performance of the house, and I think we were able to, by increasing some of the south-facing glass and minimizing the north-facing glass, kind of classic things, we were able to overcome some of the limitations of the envelope on the site.
And for those who aren't local, Sagamore, the neighborhood is not like in a grid perfectly oriented. So you're not just worried about north, south, east, west. They are on kind of fairly winding roads, right? So every house that you take on will be a little bit of a different challenge. So thank you. Mark and Kim. Mark, is this the first public panel house you constructed up to this point? I think you have others in the pipeline, but was this the first you installed?
Yes.
So talk us through just the prep and lead time ahead of time when you're not in the dirt relative to like the speed of actually assembling those. Do you feel like there was really an economy to that? I know you talked about a lot about control and not needing to worry about training, tracking through and training subs and doing everything as still stick built on site.
Yeah, I mean, I think from a lead time perspective, we really had to take that into account. At that particular time, their production from approved shop drawings to delivery was roughly about 6 months. So we definitely took that into consideration in terms of our schedule. And actually, people think that's kind of crazy, but by the time we got through permitting, started to do all the preliminary construction stuff, we were actually kind of really well coordinated with where we were coming out of the ground with our foundation, and them being ready to deliver panels. So there's that aspect of it. The training, ideally, B Public wants a trained crew to install. In this case, we weren't able to do that. Our chosen subcontractor didn't have the time to attend one of their trainings. So Be Public actually was really helpful in that regard. They sent somebody up. They sent actually Jonah, one of the founders of Be Public, up to help in guiding that installation. And I will say this: that particular project was very difficult because we had a lot of rain coming through May.
A lot of weather.
Where it really really kind of delayed us quite a bit. So it was really hard for us to get our head around what kind of advantages we had there. But I can tell you on the second project where we had much better weather and we had a trained crew, that is just finishing up with the panels, and it has gone fairly quick. I think we started somewhere towards the mid to end of August, and for close to 4,000 square foot house and this is one with 2 floors, having to frame those floors and everything. They're more or less done and windows are going in. So that is, I think we're really happy with that. And again, what I'd like to emphasize, the advantages there for us is that we feel like the air sealing becomes a much easier proposition for us with that system.
Yeah, the sequencing definitely is simplified, I would think. And the number of transitions you're tracking is definitely smaller because everything is already lapped in the joint where it's needing something. So you're just taping that seam. Frank, you guys opted for the double stud, which I'm a huge fan of. I always think, at least here in the Front Range, we have found that to be a really approachable and affordable solution to a high performance house. Can you just speak to how you've approached that project, and are there any decisions in terms of like helping drive or working with Shape to drive that assembly selection because of affordability or time, or local skill sets and crews?
The double stud was a choice mostly because we had experience with it. We'd done double stud on projects before. We had a lot of experience with it. We knew how it went. We knew kind of how to quality control. And, we had people on the team who were trained to do that type of work. And we were confident it was going to be able to be meeting Passive House standards. It's also nice when you have documents kind of showing those sorts of details and a consultant that's willing to kind of work through all those details with you. I will say I'm very interested in panelized systems to simplify because a lot of details are really tricky and you can only draw them out so much. And then you get on site and you're like, oh gosh, how should I do this? Like, what material should I use? How will I fold this thing? And, it gets a little, it's like tricky in your mind. Like it's even hard to visualize sometimes. So yeah, I think the nice thing about double stud is that framers know how to do it. It's like build a wall, build another wall. You can get cheap cellulose to blow it in, so you have a low embodied energy, somewhat healthy insulation material, super cost competitive. Blow it in, really easy, quick, fast. It's really just about the air sealing that gets complicated. Everything else is like super straightforward. And even for electricians to run things in a service cavity, other than when you want to use deeper boxes, other than that, fishing wires and things is actually kind of easier than drilling a million holes in stud walls. So I think there are a lot of advantages. I think it's one of those ones that if all else fails, just do a double stud and you probably will be fine. And that was kind of part of it too, was I think if we had started pursuing panelization, by the time we really started seriously considering it, we were probably too far along in our schedule to be able to make it happen. It's like, oh shoot, we should have thought of this like 3 months ago.
Yeah. Mark, did you order your panels before permit was approved, or did you wait until you'd crossed that threshold?
It was before permits were approved. So that was a little bit of a question.
The bold move.
Yes, it was a bold move. But we had met a lot with Louisville, and we had showed them our project a lot, and we had specifically said, please tell us any red flags because we want to go ahead. So we felt a certain level of confidence that it had been vetted and things that were going to come up in permit would not be deal breakers for the panels. But yeah, a little stressful for sure.
And then windows probably shortly thereafter, I would think, or at the same time.
Yeah, very much. In fact, windows and panels were kind of on the same lead time, although it turns out that we got the windows considerably faster than anticipated. But well, I should
no
say
one ever. So congratulations.
Within a couple of weeks, a couple of weeks sooner than we thought.
Yeah. So the other driving factor in Marshall is time, and just understanding that, you know, we've talked about this, but insurance only covers so many months of rental coverage while homes are being built or purchased or sold. And so I know that every homeowner was very determined to be back home by a certain date. And I know that those decisions have to weigh pretty heavily alongside total just budget constraints on their own. One of the questions in the chat was just about putting renewable energy back on site, or renewable energy sources, solar, geothermal. Does anybody have solar planned in their project, or have you had any time to think about the operational carbon or operational footprint of these homes that are replacing the original houses, other than they're going to take a lot less energy? No solar? I think we're all prepped for solar.
We will have solar. We have solar on ours. Yeah, everyone has. You have to run conduit by code.
Yeah.
We will have solar, but they have an agreement with Tesla. They're going to be coming back in and installing, and I'll just say that communication has been infrequent.
Yeah. Well,
but
I'm sorry to hear that.
I think we have. Yeah, I think we at least have projections, but I don't know. I'll say no.
It's such a a natural question to ask, and the contrast of construction and energy use in these houses has to just be so blatant that it's like, why would you bother modeling the old house, which was built, I don't know, in the 90s? Maggie, do you know or Kim, do you guys know, Rob, when the original houses were constructed approximately that were lost?
The Sagamore houses were all early 90s.
Early 90s. Yeah. So dramatically different. Well, everyone, thank you again for the awesome presentations. It was really great to see the details and construction photos. I'm sure we'll come back and do a final finished project panel discussion at some point with all of you. So thanks so much.